welcome to ArrayCast episode 125. I am your host, Connor, and I'm here today with the only panelist, therefore co-host for the time being, Adam. I guess we'll go around just for old time's sakes and do brief introductions, and then we've got two announcements, and we've got hopefully a fun topic, maybe a little bit different because we've got this YouTube format. But before we get to that, we'll do a brief introduction from Adam.
Right, I'm 𝗦𝗛𝗢𝗪. I've been doing APL my whole life. I do APL at 𝗦𝗛𝗢𝗪, where we create the APL of the future, you could say. And I've been honored to become the head of language design there. But I also deal with everything else dealing with the language at 𝗦𝗛𝗪.
And as always, I am your host, Connor, massive fan of all the array languages. And yes, we have two announcements I believe today, both from Adam, so I'll throw it over to you, and then we'll hop into our conversation.
Right. So I unfortunately had to announce in the last episode that 𝗦𝗔𝗢𝗪 Christensen, the former CEO and of 𝗦𝗛𝗪, and much of the reason that we've been here today, passed away. There was a funeral service for her. And there's also been set up a memorial site where you can both see a lot about her and the obituary and other things, but you can also add your own tribute. I'm sure that a lot of people want to do that. So it's 𝗦𝗛𝗪_Christensen.RIP, and we'll leave a link to that as well. And then there is the APL Forge, which is the thing we do at 𝗦𝗛𝗪 once a year, where we let people submit projects that they started in or for 𝗦𝗛𝗪 APL. And it comes to an end once a year, and then we start a new round. And there's 1 month left of this year until we stop the round, and there's the next round. And you can still, if you have some kind of cool thing you made in APL, then you can still submit it, and then we'll have a look at it. And you might win a prize and a trip to the next user meeting. So have a look at forge.𝗦𝗛𝗪.com.
And we will have links for everything that just got mentioned in the show notes. And surprise, surprise, we have now a second panelist, or technically guest. I mean, you are listed on ArrayCast.com as a recurring panelist, so I guess you are a panelist for today. How's it going, Rich?
It's not bad, Connor, thanks.
You're popping into a live stream on YouTube, so I'm not sure if you've heard, but things are different now. You know, there was the before era, now there's the after era, and in this after era, we just
you just go straight there.
Yeah, it's mostly laziness, I guess, because Bob was doing a lot of work back in the before era in ArrayCast 1.0. And Adam and I wanted to keep on keeping on, but I did not have the time to put the amount of effort that Bob put in. So he said, "What?" I thought to myself, what's the easiest way? And I was like, wait, in Tacit Talk, I just live stream. I do a little bit of post-processing, and if AI gets good enough, maybe it'll never reach Bob levels. But, you know, maybe the ums will get removed and the dead air will get removed. And anyways, it's good to have you here. And in the chat, we've got multiple hellos. Well, one person saying hello to the chat, but also Max, a.k.a. Meme God, saying, wow, it's Rich. You know, he's...
Is that Max?
Sorry?
I saw him not long ago, so...
Yeah.
In real life, so hello again.
I also saw him not long ago. I mean, he's local to Toronto, so I guess it's probably easier for me to see him than it is for...
Right, I had to fly a long way.
Yeah. All right, well, you joined just in time for a little bit of a different episode. So Rich, I guess, has no idea what's about to happen. And Adam got, I believe, if you include the time when he was reading the announcements and introducing himself, a grand total of like 10 minutes to ruminate about this problem. But we're going to chat about a toy trivial problem from Perl Weekly Challenge. We actually don't know the number. If for whatever reason this gets back to the Perl Weekly Challenge people, you clearly vibe coded, which I've got nothing. I'm a big vibe coder. I love vibe coding, but they vibe coded an upgrade to their Perl Weekly Challenge website, and it is no longer clear to me. I mean, I spent like 3 minutes. That's why we were a bit late starting this episode. I mean, the podcast people and the audio players have no idea that we were 3 minutes late, but the folks on YouTube know. and we couldn't find the past problem links. Anyways, I happen to recall the problem from memory. So this was in the last like month or two though, and I never actually solved this problem. I read it, I thought about it, and then I couldn't find or think of an elegant way to solve this. It's definitely solvable quite easily, but like I couldn't think of a kind of single one-liner tacit solution because there's a couple edge cases. So here's the problem. And I'm not sure if at some point I want to share my screen or Adam wants to share his, or Rich, you can even share yours.
I'm on the table of problems now on the weekly challenge site. So once you describe it, I think.
Is it the one that says recap, or is there like a link to, because the recap one just brings
no /challenges. So funnily enough, in the title bar, it's under the tab this week.
So
which is slightly misleading.
That's the one I went to. And then you'd think, oh, it's just for this week, but it's actually past weeks. But when you click on recap, it doesn't bring you to the problem statement. It just shows you how many languages it was solved in.
Oh, I see. No, I'm not that far. I'm just at the table of...
Yeah. Look at that, though. Like the UI experience here, two different people, completely unrelated, did the exact same thing. They found the challenges under this week, thought that's a weird place to put it. And then it turns out, first of all, it's not for this week. It's for the past weeks, but it doesn't actually show the problem description.
It's an abbreviation for this and all weeks.
Yeah.
Obviously. Go on, describe the problem. We'll see.
So the problem is, and it may be someone in the YouTube chat because we've got a few viewers, and play along as well if you're on YouTube doing this live, and also if you're listening to this in Spotify, Apple Podcasts, whatever player you use. You're given a string of lowercase characters, and you want to return the largest distance between two equal characters. So two characters that are the same. And if there are no duplicate characters, so there's no two characters to find a large distance between, you return -1. And it's exclusive of those two characters. So the easiest example is, or a couple examples, if you have the string ABC, CBA, the two characters that have the largest distance between them are the A at the beginning of the string and the A at the end. And because there's BCCB in between those, that's 4 characters, so the answer is 4. If you have the string AABBCC, there are 3 pairs that all have the largest distance, which is 0. And if you have the string ABC with no duplicates, you return a -1. And so if you want, we can ignore the -1 for a while. But even just the, assuming that there is a duplicate, actually, I guess the -1 is the tricky part, because if you were to do something like my thought process, and then I'll let the pros step in, was that you want to use where or indices to do this. Is that actually true? Or classify? I can't remember now that I guess I should have, but there's some operation basically where you want to get, actually, okay, I got to step a step back. Let's actually walk through this if I'm solving this for the first time, because clearly I've forgotten. I think at one point I was like, let's do an outer product. If you get a unique with the values or the characters in your string, you can then get like a matrix where you have a mask that corresponds for ones for all equal values. And if you did an indices on that and then some kind of, 2y's minus reduction, you could then get the differences, but then you're going to run into issues with that. And then I think I had an alternate version with where, but it still wasn't great. And the problem is that if you are going to do the first last trick, so even if you take that matrix index idea and you look at the first value or the first index and the last index, you're not going to get the correct value if you only have a single character in the case of the ABC string, because the first and the last both point to the same one, and they can't both point to the same one, right? So you have to do some kind of check to make sure there's at least 2 indices that correspond to equal values. And yes, someone in the chat.
That's just checking, like, that if they have the same position, right? Because it's the first and last are the same, then the distance between them is going to be 0. So it's only a problem if there aren't any duplicates at all, right?
Correct. Although now that
that's super easy to check. I mean, you have to subtract one,
now
right?
that I think is like a difference of 0 already is invalid. Like it has to be a difference of.
Yeah.
1.
So you just if there's AA, just simply because AA, then the answer is 0, right?
Weeks, by the way.
Are you still looking for it?
This-
Oh yeah. Someone in the comments says string largest same digits number, but I'm not sure it's that.
But hold on. Let's just think about this. If the string is AA, then the first and the last indices, right, should be 1 apart. But the actual answer we should give is 0.
Correct.
So we just subtract 1, right?
Right. And then
Now
for
the only
case where
way
it's
to get
0, yeah.
the only way to get the largest distance being 0 if every character is unique. So all we need to do is subtract 1, and then we get -1. Isn't that super easy?
That's so sad. Yeah. So this corner case that I thought made it tricky, it's actually super simple because you're going to have to subtract 1 from everything. And the case where it's 0, it actually gives you the exact value that you need.
So I think that I have a solution in Dialog API if you want me to share my screen.
Yeah. And so there was someone in the chat that was mentioning a different problem. It definitely wasn't that problem. And yes, we were saying that Perl Weekly Challenge recently vibe coded an upgrade to their website, and we can't find a list of the last problems. The hack that I was doing is if you go to this week, it shows you a full URL with weekly or week 374. If you just change those URLs to 373, 372, 371, which is what I was doing, but I couldn't figure out, I still couldn't find the exact problem statement, but it was in the last month or two. So if you, YouTube viewers want to go and try and find the link, paste it, we will then share it with folks. We don't know which week this is.
I was immediately thinking, Adam's sharing his screen and it's got the key operator. As soon as you described the problem, I was immediately thinking key in my head. Where the default gives you the indices where unique major cells, in this case unique elements, occur, and that's what you're concerned with, right? So the indices of elements.
Yeah, well, I was concerned that if you like I said, it's actually ironic that I thought this one was tricky because the problem statement actually is perfect in that getting the -1 is a natural byproduct of actually subtracting 1 from the deltas between the indices. So what I thought, and I thought that was the tricky part because you had to deal with that some way, but it's actually, it falls out of just dealing with the general case. And the interesting thing is though that both of you thought of key, whereas I guess I don't reach for key rarely ever. I always think about, I don't know.
Doesn't do a lot of group.
You basically said it. You said classify, right?
Yeah, you said classify, and that is.
That's what it does.
Classify is not an APL though, so
no, but it fulfills the same role, right? It takes these and puts them takes all the A's. So the way I thought it was key anyway, because we're not interested in A in relationship to any other letter than A.
Oh, by the way, so classify, was that the once upon a time a monadic equals in some writings that would give you that matrix? It's like a Boolean matrix.
Essentially.
Yeah. Okay. Yeah.
So this is exactly what I said, right? I said, like a unique outer
But this
product.
is what they had to do before key. Keys before key.
Yeah.
So actually, this is amazing, but I'm very excited because this is, did we have a topic for today? Adam and I were trying to figure out, and I was like, well,
this is the topic. What are you talking about?
I know, but I thought in my head, I was like, well, there's not anything like topical news and we didn't have time to set up a guest because I've been out of the country for the last week. But I was thinking, what I actually want to do is I want Adam to solve this problem that I in my head a month ago couldn't come up with an elegant solution for, and now we've got 3 different solutions, or at least 2. But let's take a step back and walk people through the first. And so someone I think has found it. Task 2. They haven't mentioned the day, but the exact wording of the problem is: you're given a string. Write a script to return the length of the largest substring between 2 equal characters, excluding the 2 characters. Return -1 if there is no such substring. So I stated it slightly differently, but it was just an alternate description of the same problem.
The only problem is if it's empty, then things will end up badly. But
𝗏𝗏, if you'd like to say what week that was, yes, that is the exact problem that we are talking about. If you say the week, we will mention it for the audio listeners. Obviously, everyone on YouTube at this point. So walk us through starting with key, because I'm sure there's people in the chat. Because like I said, I rarely reach for key, but it is in this case exactly what you wanted.
Yeah, so let's take this simple example here. We've got ABCAAA. with key, and we're just going to inspect what the elements are going to be. So the way it works is the key, or what the arguments are going to be. The key will classify. Well, it will take the array on the right as a collection, and it will bunch together all the equal elements, and it will call the function on its left with that element or that major cell really as left argument, and the right argument is going to be the list of indices where those appear, right? So you see A appears at these places, B at these places, C at these places. Now we're not actually interested in the element itself, so we can get rid of that. We're just interested in the indices of individual elements, and then we wanted to find the location of the largest, or the first one and the last one, and then subtract them. So this is the max reduction and the min reduction, and I subtract the two.
Oh, you walk people through that. I assume they know a
This
little
is
of
a-
APL,
this-
but they're shocked by,
sorry.
whoa, what is this incantation that you managed to...
Okay, so this is the fork. So this is the maximum reduction on the list. This gives the last time anything appears, and this is the minimum reduction. So the first time it appears, which could be the same, of course, if there's only one.
And to be clear, the reason you're saying first and last is because a property of these indices is that they're going to be sorted.
Yeah, of course, they're sorted, but it doesn't matter. Even if they weren't sorted, I'm actually not getting the first and last. I'm actually getting the maximum and minimum. So,
but
so I can actually make this shorter later.
It's the max and min glyphs, but you were saying first and last, which
could it's going to be
confusing if you're not staring at the screen.
Oh. Yeah,
you could also
we can shorten this in a moment
for that reason.
What do you say, Richard?
You could use first and last in this case for that reason.
Yeah, but
it's sorted.
It's easier to reason about it like this, but we can change it today, and we don't have a last glyph.
We should fix that. to do first and last because
it will be, but
compute anything.
That's true.
We can go golf later. Well, woohoo, golf later.
Okay, so and what happened over here is basically just in mathematics that if you got an f of x plus g of x, then you're allowed to write that as f plus g of x. So I used that over here. So this is the max of the right argument minus the min of the argument. So that's what's happening here, and that gives us these. We don't actually need to enclose anymore because they're all scalar values. And then we wanted to subtract one, so because we consider adjacent as having a string of length 0 between them. So that gives us all these. And then we want to find the maximum value. And if there are only negative ones, of course, it becomes -1. So this is the full solution. And this can be written, luckily, in a tacit way as well. So we can just write that. And then we can try it on these. And now because these are max and min, they're actually sorted, we can replace them in 𝗤𝗏, we can replace the minimum with the first glyph, which is fine. It doesn't really matter. And there's some more things we can do. Because this is just applying a function on the argument, but it has to be the right argument. So we can just say that we composing these. This is at top. So we say we want this function applied to the result of the function that selects the right argument, ignores the left argument. So this also works. It would be so nice if we had a last glyph, wouldn't it?
Maybe later I'll solve this. Well, I'll attempt to solve this in 𝗏𝗏, because not only do they have the first and last, but they also have, I believe, classify, which there's Rich is in the chat. I was also thinking the same thing. So Max has said that iota self is classify in BQN or swap. I'm not sure which one it is, but iota is not in BQN. They have the range glyph, but I'm pretty sure classify is actually one of like the, I can never remember, but they have like the claws or like the open boxes on their sides and the underbar open boxes on their sides. One of those I'm pretty sure is classify. And in fact,
Yeah,
I
this is
found it.
classifying, right? That's the, I think that's what
Right
𝗏𝗏𝗀𝗏 is trying to say, that
right box selfie.
so here I'll put in the, I'm not sure if the
so you want to group by the self classification here, right? That's another way to get the indices here, but key is of course very nice.
𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏.
So there is a participant in the chat
Maybe.
with a name that I find difficult to pronounce, spelled __ dash 𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏 or Z, depending.
we'll just call them Oz.
𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏. And try to translate it to J. That looks to a J solution that I can put here in the, just paste it in the SJ.
If we were on array box, we could actually evaluate it.
But this seems overly complicated because J has key. Now, I'm not an expert on using it, but
so wait, let's walk, because this is interesting, right? This was and we're going to solve this in Dialog APL this way as well, because before I said let's slow down and walk people through the first solution, you showed the unique with outer product, and the next step would be to do like an indices on each of the rows. And my JFoo is not great, but basically that's what that looks like, right? You've got to.
Yeah. So if we do like a unique.
The Oz just said it's a randomly generated name. Don't let it befuddle you. And the thing is that I don't know how to use key in J. So here we go, folks. We're taking key in J for a spin, although we're still in Dialog APL. So we'll
so
do
if we
this in
get
Dialog APL.
if we do the indices here for these, so we on each row we want to do the max index and the min index, right? That would work as well. So we can try this. So on each row, we want to get the index of the so we want the indices, and then we want the max minus minus the min, which is of course the first and last, the same thing, like this. So that then we're up to this step, and we can continue from there.
Can't you? I guess right. You don't have.
But
you don't have cells. Like you don't have a shortcut for rank 1.
No, but it wouldn't help much either.
Right. I
But
was going to say, I was thinking, is there some way to do this shorter? But I think this probably is the shortest.
There is, because you can do trickery with nested arrays. We can do this, right? Because of how scalar functions penetrate into structure. So then we make the whole thing a scalar, and then we get the unique, which is another vector. So vector equals scalar. The whole scalar gets paired up with each one. So now we've got these 3, right? So those are just the rows of this. Same thing as splitting this into its constituent cells. And now the rank 1 has
magic. You just blew through this. Whoa.
So now we can just do an each on this instead, and we get the same thing. So that's slightly shorter.
Step back to, so you've got in a fork, unique equal enclose.
Yeah, because if you think about it, let's start with not unique.
I'm thinking
right?
about it, but
and the identity function equals the enclose is, so the enclose makes this whole thing into a single scalar, right? It's a nested scalar, but it's a single scalar. So now we've got vector equals scalar, right? So we know the result will be a vector where we take this entire scalar and pair it up with every element of the vector. Now every element of the vector was those original letters. So we compare every letter with the entire vector. So that gives us this. This is the outer, same thing as outer equality, but in a nested form instead of a rank form. And if we replace the density function with the unique elements, that's the same thing as the outer product. but in nested form.
So that is beautiful. That's the same thing basically as a mix of the outer product that you had before, right?
That's a
Or a
split of this, or a mix of this,
They're
right?
bad names. I can never keep which one's straight. So a split of
it splits it into individual rows, and mixes together the rows into a single array, right? A single.
Yeah, and technically
array.
you can put the split into the tacit expression up there, and you can do the same thing. So really,
there's no
it's a
point.
two-character. I know, but it's a two. Like if you want to assign these to a function, well, actually,
yeah.
And then, but if you're golfing, this is basically like a two-character saving. So if you ever find yourself splitting.
Right. Then you can do. If you actually want the outer product, then it's shorter to write this than it is to write the equivalent. Right, you save you one character, even though it's very silly.
And it just looks beautiful, like the rotated
the
rotated horseshoe. Oh my god!
That's sort of random.
The forks that look a bit like faces.
Yeah, I mean,
I don't know what kind of weird expression this guy has.
It's elegant as hell. Whew.
Okay, so and then we just do the each here, right? So because now we have a nested form, we don't need to do rank 1. So we essentially got the major cells for operator, because now we're just operating on individual elements. And being that the result of this is a simple scalar, it all just collapses back. This wouldn't work in a boxed array model, but it does work here because of 𝗔𝗿𝗍𝗆𝗀𝗆's floating arrays. But there's more we can do, actually. I was just thinking here, because if we go back here and look at this, there's a fun thing that we actually just want the largest one and subtract the first one. So what if we could find the position of the last one in a more direct way? The position of the first. So the position of the first one is actually interesting, right? Because that we find here. Right? The position of the first A is 1. The position of the first B is 2. The position of the first C is 3. So, and it doesn't matter that we're doing the computation multiple times. How can we find the position of the last one? Well, we can sort of do it by looking into the reverse. But it's not quite, because then we get the position from the end instead. Right? So 1 is this one, and then in the B we find the position 5, but from the end. So if you subtract this from the total length, then we can see that the last A is in position 5. 1, 2, 3, 4, 5. Actually 6, but off by 1 because we're counting positions here compared to the. But that doesn't matter so much. So this gives us the last position, and this gives us the first position, which means if we subtract the 2, and then it will be the wrong sign, but that doesn't matter so much because we can easily just swap things around here. Oh, sorry, did I do the wrong thing? Sorry, should be like this instead. Is this right? Yeah, these give -1, right? Because those are the ones that don't have any duplicates. And then we just want the largest value that we've got here. So 1, 2, 3, 4. That's the distance over here. So the off by 1 error came to our advantage. We don't have to do that adjustment. So this is a solution where we directly look for the first and the last, and we don't do the whole key thing. It's probably faster.
What the hell?
In fact, we wouldn't actually need to do it on all of them. We could just do it on the unique ones, but yeah, it's fine. Do I need to go through it again? See what just happened here?
Well, and also this is only a solution for a subset of the problem, right? It doesn't handle the -1 case.
Why not? You see, the -1 came out here.
It does?
Yeah,
Right,
because we
walk
count.
me through this again. We got 3 different /𝗔𝗍𝗆𝗀𝗆𝗪 squiggles. This looks like absolute nonsense.
You're the one that like the combinators. Okay,
I know. I say
let's
this
do
from a
step by
place of
step.
combinatory logic love, folks. I'm just saying we
Okay.
were dealing with the beautiful unique equals and close fork idiom that I just learned, and I'm sure I could have used many times before. And then Adam was like, "Oh yeah, well, hold my beer," and he was like, "Selfie, selfie, selfie," you know, and then somehow had the right answer. Okay.
Okay, so here's the thing. It just came out right. I hadn't planned it. I was just developing. But so this one you understand, this is sort of a classify thing, right? Because really the dyadic iota, right? The index of has a built-in unique that we don't think about, but it's important here. Because what's actually happening is it only looks for the first position of any one element. So there's actually unique here. Right? The only thing that's not, this would give the same result if it's unique. But if we had like an F at the end, so we can't get rid of these, but they're not considered. Nothing will ever give indices. There's nothing we put over here that will give indices 4, 5, 6. Right?
I guess the problem is I never use dyadic iota. I don't think for like anything. So I don't even.
That's okay.
I'm
Like,
probably,
in my
doing
mind,
things
because
suboptimally, but like I just don't reach for dyadic iota.
okay. I mean, we look. We have real customers like doing things, and APL has this huge toolbox of amazing things you can do. But I would say most applications out there, they just look for information and retrieve information. And then do a little bit with it. And looking for information, that's dyadic iota. Retrieving information, that's indexing. That's like 90% of what business applications do, looking things up and extracting it.
Well, what is 𝗏𝗏𝗋◡? Because did 𝗏𝗏𝗋◡ borrow? They borrowed the membership. Well, I guess I can. Well, I don't want to. But anyways, yeah.
Anyway, let's go through this. I'll explain it. Okay, so index of, it returns the first index of. Like, it even exists in like JavaScript. There's an index of. That's dyadic iota, right?
Sorry, say again.
Say index of even exists in like JavaScript, and it's the same basically definition. The only difference is what if it's not found, but that doesn't matter here.
Well, so I think the problem is that maybe this is what I'm thinking, because 𝗏𝗏𝗋◡ has both index of and this one's called element of. And if those are the same thing, and 𝗏𝗏𝗋◡ has borrowed.
No, that's not the same thing. Element of is this, right? Oh, sorry. Right? That's if it's a member.
Did you just type that, but it's not a member? It's not in Dialog APL.
Membership?
No,
Sure.
he's using the new font.
Okay, so this is no. So okay, I'm not. I was just trying to maybe think that like maybe I use it all the time, but in a different language. But yeah, for whatever reason, I just don't use dyadic iota. I don't know why. What I'm doing in the cases where you need it. But anyways, continue.
Okay, so we need to look up the position of something, right? So we're looking up the position of everything and stuff. So that's essentially has like a sort of a nerfed unique inside, because we only consider the first time an element appears. So all the A's get mapped to position 1 that is there, right?
Mm-hmm.
So automatically this gives us the first position. I'm using this property that dyadic iota will give us the first location of any one element to get the first locations of all the elements. So this is all these numbers are the first occurrences of all the elements.
Right.
Then I want a variation on dyadic iota. I want the one that gives me the last position, but that's not built into the language. Then I'm constructing that piecemeal. So how can I find that? Well, let's say we start by reversing instead. Right? So if we reverse, then we're looking up. Think of this one as being reversed. So this is position 1, F. This is position 2. This is position 3, and so on. Okay? So A gets mapped to 2. F, A. Right? And B gets mapped position 6 because we're counting from the right. But we can't compare indices counting from the left with indices counting from the right. So how do you swap which direction an index is counted from? You do that by subtracting them from the total length, and then you have an off by 1 error, but I'm not worried about that. Right? So basically, position 5 from the end is position length minus 5 from the beginning. You with me?
Yeah.
Okay, so that's exactly what I'm doing. So we'll take these numbers and we'll subtract them from the length. So we'll take the string again and subtract. Okay, this is the position from the beginning. So the last A is in position 5, except we have an off by 1 error, but that doesn't matter. Position 1, 2, 3, 4, 5. So yeah, off by 1. But since it's consistent, I'm not worried about it at this point. Really, we want, because of fence post, whatever, we want to add 1. These are 0 indexed now. Okay, great. So we have the indices here. And we do, actually, it should be the other way around, but it doesn't matter. So we're subtracting the last position, right? So, sorry, we're subtracting the first position from the last position. That's why I'm commuting the minus. And that gives us these numbers. And luckily, we're off by 1, but we needed to subtract 1 anyway for the problem statement. So it all works out, just happens to be. And from here on, everything is like we did before. We just need the max value. So, all good. Now, of course, this is longer than this. So I'll show you how we get there. Okay, so everything, notice that this works out very nicely as a train. Immediately, we can see that because we've got a bunch of functions and all the arguments are the same. Okay? So if we try to first define this as a diff, I think that makes it easier to see.
The easiest first step.
Right, so let's just do that down here. We'll put the argument right over here and replace them with omega, so we can, because notation is really important, and being able to just spot the patterns is much easier if you have a symbol than if you have a whole distracting string. Okay, get rid of all those pesky spaces because they're also just distracting. Okay, so all good, this works. We can even try it with all our test cases. We do it on this one, we do it on the ABC one, and we do it on the one with like all adjacent like this, right? Shouldn't this give 0, by the way?
No, I think that's right. It's still.
Oh yeah, it's why there's one
one
in between. Yeah, it's not AA, right? It's
just
just yeah. We could do one more that goes.
Rich,
yeah.
with
Sorry.
the save there, Rich. I like that.
Thank
I
you.
was also thinking
I
the
mean,
same thing. I was like, oh yeah.
No, because I changed the case from before. It wasn't AA, right? Okay, so now we go through this. So this one is a selfie, right? You spot that. So this isn't a commute. This is actually a selfie. We'll do that. This is the length. We leave that for now. And this pattern is exactly the new thing in version 20 of dialog, right? Where with the behind
The
operator.
Sigma combinator. Everyone's
Right, so
favorite.
So we can
combinator.
type this like this. Okay, so this is our next step. I should give the same thing. And at this point, we're basically ready to go test it, because we now have 1, 2, 3 functions that are applied to the argument. We have got intervening functions with them here, and then we got an atop with the last one, which just works out beautifully. So get rid of that one. Get rid of this one. I'll get rid of the parentheses later.
That's cheeky.
There we go. And now we get rid of the parentheses. Like that. Yeah.
Max has a great suggestion. Can you inline trace?
I might be able to. Let's see.
I'm interested to see how whether this
Yeah,
clarifies
so
anything.
this is the new inline tracing in version 20. We can make this a bit bigger so we can see that this is the argument in array notation. And so this is the function here, and it's being given this right argument. We're now stepping into it. It's parsing through this basically, step by step of the train. It's working so far. Stepping into this, which is just a derived function. Finally, we're going to remember it's behind. So first we apply the reverse on this argument. And then we can say now this one is being applied diagonally, so it opens the window over on the left. It's working beautifully so far. So now we're looking up the right direction array into its reverse. and then we are applying the length here, doing the subtractions, 7 minus all these indices we computed before. Then we go find the selfie, we step into that, so we can see that it's the same argument being applied twice with the right and left arguments of iota. That gives us all the selfie indices, and we subtract them from the indices we computed before, the last position ones. We flip the arguments for the commute, and then we have all the candidate numbers, and we take the greatest one and can return. I'm not sure what this. Oh, right, now we're doing exactly the same thing on the second one, because we do this in each, right? So we're stepping through it. I'm not going to actually go through the whole thing with all of them, but stepping in all the way, reverse, index of, length, do our subtraction, the index selfie, and the subtract to get all the candidates, and that's in all negative ones. Okay, I'm just going to step out of that. So I just think it was a great demonstration of using the inline tracing. Good call.
All right, there's a bunch of things I want to see.
How did this compare in length to the other solution?
Can you put this original
one,
solution? It's already, I guess I stored as F. Now this new solution, and then also the indices, or because then there was the one. Well, actually, which one?
There was just the one where we re-implemented key in terms of outer products, right? There's no point. That's what key is doing anyway.
Well, so I want to do the compare X on a like random string of 26 lowercase, or like maybe 1,000 lowercase.
Sure, we can do that. So this one is F and this one is G, but we don't. I mean, the outer product one is going to be terrible.
It's all right.
We can do it if you want.
Well,
okay, sure.
Let's do it. Nobody knows.
So we want
to. I can't reason.
Which one do you want to do? The nested one or the flat one?
Let's do them both. Let's do them both. Let's have fun. Let's go wild. Let's go crazy.
Drag race them all, yeah.
And so while Adam is putting this together, compare X, or maybe there's like 4 different ways to spell it, runtime, etc., is this beautiful thing that is in the dialog APL REPL, or I guess this isn't the REPL, this is the IDE or whatever you call it. But you can basically inline profile things with like little Unicode boxes, and it's always a fun activity when you have multiple solutions to different problems to see which one is going to be the best one. And I would guess.
Sorry, a couple comments. 𝗔𝗿𝗍𝗆. I mean, yeah, it's a dyadic iota is exactly. Oh, index in is what they call it in 𝗲, is that right? We call it index of, and then JavaScript has index of. But yes, that sounds like the same thing. 𝗏𝗏𝗏. I want to add inline tracing to my own language. How much would you say that the language design disables this? I mean, it's just about whether you can pass things at runtime, isn't it? In order to have inline tracing.
And also, just FYI, 𝗏𝗏𝗏𝗏 is actually, I believe, I'm going to kill myself if I get his name wrong, Chris from the 𝗦𝗛𝗢𝗪 and 𝗦𝗛𝗢𝗪 YouTube channel and podcast.
Oh, for real?
Yeah.
Which
it is.
We interviewed, right? On Aircast? I'm almost positive we did.
Christopher.
Yes, Christopher. Okay. God, you're getting old when you're like, is my memory going to work in this instance? And then on his YouTube channel, podcast, all the same thing, I guess. They interviewed Marshall one time, which was a great interview.
Mm-hmm.
So anyways, go check out the past 𝗏𝗏𝗏𝗏cast and ArrayCast episodes. And right here we got now Madeline Bergani. Tiny Apple. I was saying earlier in the podcast, I'm not sure if you just joined live at this moment, Madeline, or you were listening at 2.0 x speed to catch up. But I was wondering if Tiny Apple had classified, because I couldn't find it, but maybe it existed under a different name. But then also too, classify gives you the different indices And actually, is that what you want? Because the different solutions we've looked at are, you end up with the matrix or the nested array, which then you can do your indices or your, min-max forks on. But if you have classify where they're all jumbled together, can you actually do anything with that without, having to split them up into the nested array that we got anyways?
So I have a question for you, Connor. I can start doing the timings now, but the data is a bit interesting. If I just do random letters from the alphabet, we're going to have very few duplicates. There's also a question of how big should we make these?
Make it
right?
1,000. Make it just 1,000 character string. That's all I want.
1,000 character string?
Just 1,000
Just a
character
single
string.
one?
Yeah.
Okay, and then we want to do
Okay.
F, G, H, and I. right?
Can we see the string? Let's see the string. Show us the string. Show me the string. There we
You
go.
want me to scroll?
That's pretty good.
I mean,
and everyone always says, "Oh, blah blah blah." You got to.
Can you show all these? Have you got the
Wait,
defs
988?
out in a row?
I don't remember if it will. Yeah, it will show.
Is that all of them?
Ooh, very nice.
Never mind D there. We can erase that.
I'm no D.
That's
Yeah.
another thing that was just lying
There's
around.
the- and also the pronunciation might not be accurate.
Good
in
thing you
depth.
didn't have any.
No, it is.
scandalous
It's the only
functions
time
in
it
there, Adam.
fails. Yeah, the only time it fails is if you got things that have to be parenthesized, but it doesn't seem like it.
But our
Like-
intuition is H and
This-
I.
this one,
are gonna
right?
suck
Wait,
because
before we do
they're
the
both
intuition. So
Oh,
just
sure,
just as a recap,
Never
we've
mind.
got 4 functions here. They're called F, G, H, and I. Not that matters. F corresponds to the key solution that we showed right off the tap. Very beautiful. Right off the tap. Right off the top. That's the problem with live streaming, folks. Your speakos end up in the final cut. Then we've got G, which is I guess we lost a selfie along the way. It was the selfie. We're using the Sigma combinator that we walked
Yeah, we
through.
don't need it for this one because behind, right? So there should be one here, right? Because it is essentially the self index of with this behind tacked on, but the selfie is implied when it's monadic, so there's no need to do it. That's why I removed it here. Does that make any sense?
Okay.
Because if we don't have a left argument, we just use the right argument on the left, so it doesn't make a difference.
So, yeah,
but it was to show the relationship between them.
Formerly triple selfie, now double selfie. And then H and I are using the same min-max fork idiom, but one of them is using the unique outer product to get the indices corresponding to equal characters on each row. But then we learned the beautiful unique equals enclose fork, and the majority of those solutions are the same. The interesting thing is after we profile this will be is it going to make a difference if we go in and replace some of the mins with firsts? But first, let's just compare.
Oh, yeah, right.
And is it running?
Yeah.
Oh, look at that, folks. We
So
skipped the intuition.
another thing I changed
no,
a
we
little
skipped,
bit.
analyzing the thing before, but
I ungolfed a little bit because of it's more efficient to do the max first and then subtract one from a whole bunch of numbers and then do the max. Right? So I changed that a little bit as you were talking.
That's fun.
But it doesn't make a huge difference.
Well, so I mean the listener. I mean
This just looks wrong.
we could still do the intuition, even though now we've run the expression. What were you going to say, Rich?
just blind. I'm just covering up in my own view. I'm just covering up
For the audio listener, he's got a hand over the bottom half of his monitor.
where the
wanna
compare
predict?
results are, but it doesn't matter because it sort of matches what I thought, except for Adam had already, if you were listening earlier, given the game away about F and G. The obvious big differences between. That's a lie, actually. I mean, it's slightly surprising. So H and I expected to be a lot worse because they're both doing essentially outer product comparisons between the entire
Yeah, but it
argument
doesn't. It's
and the individuals.
remember, it's not n squared. The unique is very small. Yes, there are 1,000 elements, but we're only comparing them to
26.
26 of them.
Yeah,
Right? So,
okay,
so it doesn't matter as much. And the same thing goes for the difference between nested and flat. In this case, very little because there are only 26 elements.
Mm.
So it would be much more interesting to have many more different elements that it could be.
I mean, we can do that.
You can just do it with
If
numbers.
you want to add digits and uppercase
A
letters,
random other.
just use
Unicode.
numbers.
Oh yeah, just use numbers. Yeah.
What am I doing here? Yeah.
And then,
well, actually, first before you do a bunch of numbers, just do 0 to 25 or 1 to 26 to see if we get the same. Because you never know strings versus integer arrays.
Yeah. No, we do know.
We do.
If then, yeah, because the characters and small numbers are stored identically internally. So yes, we do know.
Show me, and I will believe
Yeah,
you. I've as a former C++ compiler.
Okay, so here
As
instead
a
of
former
indexing,
C++ engineer, I trust nothing
Right.
performance result wise until I see it, because there's
So we
so many
just-
times where I've been like, well, obviously it does this,
doesn't matter.
and
Okay,
profiling
so we
is-
can do this.
and for so I'm not sure if we actually fully.
It's like 1 bit difference in the internal representation between the numbers and the thing.
Whoa! Look
hold
at
on.
that. Who was correct? Me.
1 second. No, did I make a mistake here?
Maybe. So wait, and also why Adam is potentially fixing this. In case it wasn't clear for the audio listener, because we did some intuition, but then I'm not sure if we fully recapped. For the character string of uppercase letters, the slowest by a factor of 2 compared to the next. Actually, I guess we should do it as compared to the fastest. It looks like it's about 5 times, 6, 7 times slower. So it's the slowest one was the key. Then the outer products. The outer product and the kind of idiom that is similar to that, the unique equals enclose, are very close, but the outer product is slightly faster, and that's about half the speed of the key. And then the fastest by far was the double selfie using the dyadic iotas. And now Adam is trying to fix the integer to match.
No, is that function that Rich was warning about? The defs that removes too many parentheses. It in fact did remove too many parentheses, despite my thinking it was good enough. And we can see here, if we compare these two, I'll run this one again for the. So
yeah, this one, I guess the noise between the outer product and the unique equal enclose.
No, these two have to compare. This is the numeric one. This is the text one, right? They are virtually identical.
Okay, yeah. So that's just to say that the noise between the last two solutions, H and I, that were the outer product unique and then the unique equal enclose, those are effectively, you can count as the same, because there's between the solutions, one was faster, the other time the other was slightly faster, and one of them they look identical. So the point being is key is by far the slowest by like a factor of 6, and the H and I, the outer product, and the equivalent, fork, unique. What do we call that in idiom? I guess we just call it unique equal enclose. Those are about 3 times as slow, and then the fastest by far is the dyadic iota, which why is key so bad?
Because key in this case we're giving it a
custom operand.
Yeah.
That's a good point. If you rewrote this so that instead of a custom operand to key, you just did enclose omega. So
Yeah,
you
maybe.
basically just
We can
rephrase
try.
key to become what it seems in BQN is in group. Sorry, yeah, just group indices / group.
So we want to do
So,
this.
and it has
Something
been
like this, right?
argued that this is a way to do it. So, like a little under the covers here is the sort of rationale behind some operators. At least in dialogue, is what you can do is because you can inspect the operands at runtime. You can see what the functions are actually spelled like. And by doing that, you can take some of those operands that you expect users to use and optimize them as special cases. Right? And that only really works with operators. But of course, it means you have to spell things in a particular way, unless you have, something that's something like just-in-time compilation or something that can track. There's this idea that floats around called thunks, which is keeping track of things that have not yet been computed or that you intend to compute, and then passing that information along to future functions, and then they can look and say, oh, you said you were going to compute this, but actually, since I'm going to compute this other thing, and I know what you were going to give me, we can actually do this other thing that's faster instead of materializing intermediate values. Anyway, that's
So,
the rationale. But in practice, you know, it's hard to anticipate. It's hard to produce all of those special cases. But one of the special cases for key, for example, and stencilers like this too, is just group the stuff and give it back to me as a nested array. And that is so fast with the special case that sometimes it's a lot faster to do the grouping and then apply your operand function with each instead of applying the operand function directly.
Yeah, so now this must have been a fluke.
performance tip.
Something happened over here that made it run slow. Here it is again. We can recognize this pattern from before, but now the key one is much faster. It's faster than the outer product ones.
Right, which is what I would have expected.
Yeah,
So
the
what was
only
the
thing I
small
did was
change that you made here?
so if you compare F that we have,
You put them next to each other.
Yeah, I'm going to carry them down there.
Cool.
F there and F2 there. So firstly, I switched to the explicit because too many tops. But basically, what I did here was instead of feeding this giant custom operand to key, I'm just using this operand, which would be slow because it forces nested arrays. But in fact, it is a spelling that key recognizes. And instead of going through all these motions, it knows exactly what to do. Exactly, it's internally optimized, and so we go from there. Another thing that's interesting to look at is instead of max, we want to do first and last, so we can try that as well.
Yeah, if you could do right tack, you just swap them for the tax.
Stations from
right
tack
and left.
What do we call
So,
it?
but I mean,
𝗔𝗿𝗀𝗃 or whatever. Or I guess.
It doesn't matter so much. We can just call them. I just have to find them. Here, this is the F1, right? So this is FA. We want to replace the last and the first. We can write like this. It doesn't matter if it's how it's
fine. Yeah.
And we want to do G. Doesn't matter. It's the same thing. It's obviously going to be fast still. And here we want to do the last one and the last one and the first one and the first one. F, G, H, and I like that. And then we want to
expect these to be faster?
Yeah, a little bit at least. I'm not sure if
it
matters so much in the grand scheme of things, but we can try it.
See, this is where I have what do you call it? I guess I don't have a name for it, but like there's these optimizations that you can make. I mean, I guess this stuff is built into interpreters like Dialog APL and BQN, but like I've always said if you keep track of the sortedness of stuff, like you can make optimizations. Like if you ever call min or max on a sorted sequence, it'll just dispatch to like the first or last. But then people say, like when would you ever do that? This is an example of where having those kinds of, because I know that like I'm not sure if Dialog tracks it, but I know Marshall said that in BQN he has a bunch of these like metadata flags that track the sortedness and whether it's Boolean, etc., and then they dispatch to different algorithms. This would be a perfect example. Like if we saw no perf difference, you might be able to assume that because the indices of the result of these operations are always going to be sorted. If you're able to track that, it would. And as Madeline's been posting in the chat. Ooh, here we go. Never mind. We'll talk about
the tiny APL. Yeah, we'll come. I want to look at the
should
tiny
I,
APL.
should I have sorted these? Or?
Yeah, just can you do the defs underneath this, and then we can show it all on one screen?
It's sort of I can, but remember the defs doesn't show it really correctly, but it gives an idea what is supposed to happen. Because it's missing parentheses around a bunch of them, but it doesn't matter so much.
What's happened that's interesting? Yeah, okay, we're trying to do the right.
So we really want to compare F with FA, so that's 9% faster there. We want to F2, it didn't matter.
F2 with F.
Oh,
yeah,
I
but the main
messed up
optimization
F2.
is.
Sorry. No, I messed it up. I'll redefine that. I messed it up. That's F2, and we want to do an F2A. Is this one?
Or you should just compare two that are the same with rights and lefts instead of max and mins, instead of trying to put them all on one.
F2A, but what I was thinking as we should do is just sort these. So that makes it easier to do it. So how do we do it? At top.
Behind
For the
square
audio
up.
listener, the last index of double selfie solution is still the fastest, but looks to be small improvements to replacing the min reduction with a first. And I guess I was gonna say, did you replace the max reduction with a right reduce, which is optimized?
We can't do that. We can't do that here because you don't know which one is going to be the largest one. There we actually need a max. Right? It's only the ones to find the indices, the first and last index. Those are the ones that we can replace. Why do I have two F2s? Doesn't matter. But this shows us something about it shows something about the accuracy of the results.
Oh,
so
no, yeah, because F2, because you wrote F2 twice.
Yeah, I wrote it twice by mistake. Doesn't matter, but that knows that we can't, as everything is like plus minus 5% anyway.
Yeah.
So F2A, we can see that it really make a difference from F2 to F2A. And FA is significantly faster than F. G, it doesn't matter because it doesn't use that technique. You can see these. The HA is slightly faster than H. IA is slightly faster than I. So yeah, it does make a difference.
FA versus F, where it's the biggest difference. That's probably where it's.
That's probably no. Yeah, it's the same. Like, it's the same sort of percentage-wise difference, isn't it? Out of the whole total work.
But they're directly comparable.
Yeah.
Because they're literally the same, except one's using rights and lefts, one's using max and mins. And
so there's another thing.
I guess
this actually, it's interesting. Yeah, why?
Because the number of times it's running should be the number of times it's running should be, it's just the number of unique elements for both the key and
the way key is
F2.
slowing everything down. Yeah, I don't know. Yeah, I'm not sure why it's the same relative difference. Everything, maybe keys just slows everything down inside itself. So the relative difference between max and mean just gets exaggerated in there. I don't know.
Maybe every time. I don't know.
Here's another thing. No, and here's another thing. Key might reparse its operand every time around the loop, but right tech reduction and left tech reduction are tokenized as such. They're two glyph tokens actually.
Oh, right.
So it doesn't need to reparse them. It's not actually a reduction at all. It doesn't go through reduction code at all. It immediately goes to the last major cell function and the first major cell function, which are primitives in the interpreter, but not in the language. So, yeah, okay. But as you can also see, it doesn't matter if we're using numbers or characters. If we compare those two here, it's exactly the same time.
Do we want to? At one point we were gonna change it to have way more
possibilities. Yeah, so now we can do that, right? If we go up to, well, we could just do it here. So if you do big N is 1,000 reshape 1,000 instead, right? So now there are much smaller chance of there being duplicates. There will be some big duplicates, right? So if you do G is the fastest one, right? So there are duplicates and they're far away from each other. Birthday problems abound here. Want to run the unique on this as well? No, it doesn't matter because we need. What do we want to run all of it on this big one as well? I guess so.
Why not?
I guess I was thinking more just comparing like key and outer product, and so like just GIH. Or whatever, we can pass it afterwards. Madeline's index of solution by far the slowest.
We'll show this. I mean, you guys aren't going to see this, but I've been compiling Madeline's solutions. I mean, if you look at the YouTube stream, it'll show up in a couple seconds for you, or now. But Madeline has a couple different solutions. We'll look at this in a second. She's mentioned that her index of is the slowest, but that's just an implementation thing. But anyways, the solutions are back, folks. And
now there's a big difference between some of them. No, because they're in a different order as well, so it can't really. It's hard to compare. So now there are many more. We can count the unique, right? Tally unique n.
So there's 634 unique values.
That means there are very few duplicates, right?
And so just once again, because we've been, we're watching this on screen, so we don't have as much confusion as I'm sure the audio listener does. Definitely just go watch this on YouTube, because honestly, this is valuable educational material, folks. I'm learning a ton, and it's probably way easier to follow along if you're watching the video. However, if you really do like the podcast format, what we're doing now is we switched from our 26 possible characters in a lowercase or uppercase string to now an integer sequence of up to anywhere to a maximum of 1,000 possible values. And so in this test sequence, we have 1,000 characters, and we just did a tally of the unique. And so there are 634, much higher than the possible 26 unique characters. And now we are going to see the impact on the profiling of the same solutions that we just looked at for the character string. So yeah, my guess is, I was going to say,
so
if he's looking for the maximum, I was going to say it's either 1,000 or
he's looking what's the most occurring thing.
Yeah, so the one that has the most duplicates has 5 duplicates, right?
Interesting.
So this is a different set that we had before, and they're 2-byte integers. Not that it matters a whole lot, but yeah, you can go looking for 64-bit floats if you want. Or
so the trend is the same. It's just more exaggerated. Where we had a solution that was 6 to 7 times faster, the index of compared to the slowest one. You can see
FA and F are the ones that are really slow. The key solutions there. The F2, where we broke out the post-processing of the result from key, it takes half the time basically as before. It helps a little bit to do first and last as before. Here, this is plus minus 5%. So by now everything is drowning out, and this is 5% faster with the first last. The fact that this one is slower than its first last one, I wouldn't take that at face value. I would remeasure that if it was, because I don't believe it. I mean, CMPX, we just try it. CMPX, H big N, and HA big N. I think it's just noise and drowning because of the other things that are going on. There we go. Yeah, that's expected. So yeah, first last is better. I also get something out of this. This helps me in bolstering my view that we should add the last primitive. I think that would be like even conceptually a nice thing to have. So we could do like last minus first. That's one thing.
Oh, because
and the other thing,
because people don't necessarily reach for the right tack reduce idiom. It's more of a thing that some people might
it's more
reach for.
obscure, right? And it's not the same either. Right tack reduce is last major cell. This would be last element in Ravel order. It's not the same.
It's last.
Just like
it's not even last column.
Well, it's last. Really should be like this. This is last major cell.
Last.
Right? So if you do like,
oh yeah, that's true. Sorry, yeah, it is last major cell there.
Right. So
how you want to write it? Yeah.
And this is first major cell. Right, and then we've got first column if you
right
want.
tack slash bar, left tack slash bar.
And yes, sorry, I should speak this up to the listeners. And left tack reduce, right tack normal, like last axis reduces. Those are left and right columns in a matrix and not very meaningful in a higher dimensional array. And then we've got a first function that this as a disclosure one, right? It picks out the first element or coerces one out. That's another difference, that you can't do last element with a right tack reduction over an empty list. But you can you can't do the first one either, but you can get the first element which coerces out a prototype. So how do you get the last one? So there actually is a built-in idiom thing where this tokenizes, but there's not always the combination and ends up nicely. You might need like in a top. So there's a first of the reverse, which is also seem to be slow, but isn't if you're lucky. I think it would be nice to have a reverse, a last glyph, something quite
Mm.
often, especially in this case, it was actually first and last. But I find that it's very often I want to operate on something that has exactly two elements, and I want to be able to address the left element and the right element, and that's also first and last. So that's something I want. So that's one thing that this has done for me. Another thing it's done for me is this exact thing of key with the enclosed right argument. That means key that just works on the indices and returns a list of indices, lists of indices, is an extension to key that's key with vocabulary essentially.
This is just a group by function.
Sure, but key with vocabulary does exact my proposal for key with vocabulary.
Would do that as a monadic
as well,
application.
right? Yeah.
If no, you have to provide the vocabulary as.
Yeah, but in this case with the alphabet, we know what the vocabulary is.
Sorry.
Yeah. So if
So
if we were to write,
how would you spell it? So right now we're doing open curly brace, enclose omega right curly brace key, and that is the group by function returns a nested vector of your
so with the vocabulary, it wouldn't.
Each.
What's it called? Let's see if I can find this.
But Adam has a proposal. Well, for key in dialogue, at least, one of the bugbears is that if you want to sort your results, or if you want to have sort of you want to have results that include zeros, for example, where an element type that you know about doesn't occur.
Yeah.
Then you have to prepend basically onto your argument, and sometimes onto your set of keys, a vocabulary, a set of. You have to basically prepend with the unique elements that you're interested in the order that you're interested in.
Yeah. So if we do this, right? If let's say we want to find letter frequencies, so here
word abracadabra. So
right. So this is not a useful result because we don't know what they are, right? And even if we do put in the left argument here, so we do like this. This doesn't give us the 0 for all the letters that are missing, right? How many X's are there? We don't know. It doesn't say. We have to fill that in later. So that's a bit annoying. So the key with vocabulary, which of course it can do the same thing, but we can basically tell it. So if you go back to just this here, so we tell it instead that the vocabulary is the alphabet. And now it gives us even the letters that are missing. And then we can go in and check each one. So this is, again, this pattern of actually wanting this and actually wanting for all of them. In our case, it wouldn't matter because first and last, it wouldn't have made a difference anyway.
Oh, we explicitly only care about the
ones that are there
in the argument for the per weekly challenge.
Sure, but here's another problem then. So let's just say that we did have key with vocabulary, and now we want to do the first and last. Right? So we get these lists here, and one of the lists is the empty vector, and now we want to do the last minus the first, and we get an error like we said before because they're not the same. Really, what we want to do is we want to get the first, which we can get, which is 0, and the last, which is 0, and subtract them from each other, which is 0. Right? And then it's all good. But we're missing the last primitive.
Yeah.
So let's get that.
Yeah.
Also, too, I totally forgot that. What was it? Let's go get the username. Was it 𝗔𝗿𝗍𝗪𝗏? We said that we would mention the week if they found the number, and they did. And then we were steeped in the solution. Did we say it? Was it 372, or did you say it, Rich?
It is 372,
It is
whether or not it was said.
Oh yeah,
is-
yeah. So we might have failed. What are we? We're at the 80-minute mark, and so we might have failed to mention that this is. I mean, does it actually matter? Not really. But for folks in the future that are 80 minutes into this, being like, "Why? Where's the problem statement?" And potentially too, this is kind of a classic interviewee. I bet if I search this on Google, it also corresponds to like a LeetCode problem. Anyways, back to you, Adam. Sorry.
No, it's fine. I'm just showing how the key that always uses that function, but with vocabulary, it would still work because we'd get these distances being 0 here.
Yeah, but then you get a bunch of negative ones for things you don't care about. Or
It doesn't matter
in the
because we
problem.
want the maximum, right?
Oh, you're right. Yeah,
And then subtract 1, so
sure.
it actually doesn't matter.
Well,
And it is indeed LeetCode problem 1624 with a much more specific name of largest substring between 2 equal characters. So I was thinking about this because I was like, what am I going to call this episode? Should I call this episode like key versus index of versus outer product? Because honestly, that is what's more, I think, important here is like we're discussing the trade-offs between primitives, how it affects your solution. Or do I call it like PWC 372 part 2, which means absolutely nothing to like people out in the interwebs, but like will mean like when I think about this episode in the past, like I will think about, oh yeah, that's the time we solved that Pro Weekly Challenge problem. Like, so it's what should we actually call this? Because currently this episode does not have a title. The repeat listeners will know that we just called it 125, and we're gonna add a title later. So
Yeah, it was a big problem for us at Dialog, by the way. And our website people were unable to put this episode on our calendar of upcoming events because there's nothing to put in the title. See,
they can't just put ArrayCast 125. That's not enough information.
I guess not. That's a value or something.
Choose in advance if you're not interested.
So yeah, I think this is pretty neat. I would think that key with vocabulary can be made faster. My model isn't intended to be fast in any way, but I would think it could be faster because key, when it starts working, normal key, it doesn't know, with this function of enclose omega, it doesn't know how many unique elements there are, right? It will have to traverse first and find out what are all the unique elements, or as it goes along, it will have to make more and more result collection pockets where it's going to keep adding indices, but it doesn't know how many they're going to be. So it doesn't know how much space to reserve for each one of them either. I would think that it would be advantageous for key to know in advance that I'm only looking for these 26 letters. That means if I find any elements that are not among these 26 letters, I'm not going to consider them. Just going to skip them. So it knows it can start building up slots of 26 slots.
But it doesn't know how many it's going to find, so I don't think
that's true. But now it has some bound on them. It knows there are going to be a great many duplicates. So it could at least, on average, or some kind of I don't know, geometric average thing, it could start off by reserving like twice the, or something like that, the total number of elements divided by the number of elements we're looking for, something like, because it knows it's going to fill at least quite a few of them. Then you can always compact it later. Something like, I mean, I'm not a C programmer. I think some things there's some tricks they could do to sort of do best guess and compact things later rather than having to be completely blind to what's going to be later.
Indeed.
And you could what if this works in the model actually? Yeah, so
Connor, as we surpass minute 83 or so, you had the collection of Madeline's tiny.
Yeah, should we show those
solutions?
You want me to stop sharing? You can show those.
Yeah, I'll steal. How do we do this?
I don't know how this
entire screen
Google Meet works.
This is a little behind the scenes for the YouTube people because they can see for like 3 seconds my monitor, my multiple monitors. Show my screen anyways. There we go. And so now I'm going to be staring at my top monitor, even though,
you want to click that button.
What button? Oh yeah.
Yeah, the
Well, so
one you
you're
just
behind
did.
now,
Yeah.
but if it depends on whether you're watching the
So
YouTube
what
stream.
page is this as well? Is
Th-
this the
This
array
is
box?
my array
This is
box.
Is this the array box that's up?
Yeah, and it's beautiful, folks. I mean, I tweeted the other day that the AI hack is I now have like I've gotten the AI to program me GitHub actions that like monitor when there's ever updates to 𝗦𝗛𝗢 and 𝗔𝗿𝗏. And then whenever it notices an update, it automatically kicks up another GitHub action that goes and like pulls down the source, compiles it, gets the 𝗦𝗛𝗢𝗪 executable. So now every once in a while, I just get a pull request on this repo that says, hey, we got you the new version. I just click merge. It's beautiful. Everyone else was upset. They're like, oh, you've exposed yourself to supply chain attacks. Listen, folks, if I get a supply chain attack, we're doing great. That means that people care enough about this website that they want to uproot what I'm doing here. So we've got all the different languages.
But you're only pulling from trusted people, right?
Exactly.
These are all the array programmers
Someone
you know
would have
personally.
to corrupt one of the array languages.
People are just so anti-AI that like they're like, oh, that doesn't work. And it's like I used to do this manually, and it was so just like laborious. And now it's so pleasant. I just like I wake up in the morning, I'm so excited to go to my computer. I'm like, ooh.
You heard that first, folks. Here, if you can put in a supply chain attack that puts some funny message on arraybox.com, Connor will give you a prize.
Hey, I did that first.
Madeline, yeah, that's true. That was before. You were one of my
first day and went live, and then was like, "Here, kind of trust AI too much."
Yeah. The sad. I gave a talk
Madeline's
recently.
Not to be trusted.
Yeah, Madeline saying in the chat, "You shouldn't trust me." And it's like, "Oh, well, that's my own fault. If you want to take down ArrayBox with a, malicious release of 𝗏𝗏𝗡𝗏, it serves me right." But I was giving a talk recently at NDC Toronto just like a week and a half ago. And I used 𝗏𝗏𝗡𝗏 for all of the code and like live coded the entire talk. And the reason that I used 𝗏𝗏𝗡𝗏 is one, it has all the primitives. When you look at the keyboard, it's just like, holy smokes, we got everything, folks. And that's fantastic. In fact, I was thinking as soon as I was solving this in my head at the beginning, I was immediately mapping like, what languages have primitives that would be a little bit nicer. And I thought, oh yeah, 𝗔 has decrement and increment, which is +1, -1. That'd be nice, except for the fact that there are actually 2 characters in 𝗔, so it doesn't save you anything compared to like a -1 or a +1. And then I forgot until I saw Madeline's solutions that, oh, that's right, 𝗏𝗏𝗡𝗏 pretty much has everything. And so if you look at what the double dash except in a single Unicode primitive, this is decrement. So you can, I don't actually know if this saves, probably does save 1 character. But anyways, I was mentioning that the reason I used 𝗏𝗏𝗡𝗏 was one, because it has all the primitives. Like I would have typically used BQN, but BQN didn't have the partition functions, partition and close. And so I needed those. And then when you think, why wouldn't you use dialog APL? Because dialog APL has those. However, if we quickly copy this and we go to dialog APL, if you try to output multiple things, so if I do, what do we just do? I guess we can just type a thing, and then we do 4, 5, 6. Because of the safety mechanisms that I put in place, you can, well, is it because of this? Usually, actually, this says that I can't do this, or maybe this isn't because of, but anyways, I'm using the safe3 dialog thing, and I don't know if that's what prohibits this, but multiple outputs don't work, whereas 𝗏𝗏𝗡𝗏, I have no problem.
It just struck me now. I was at the BAA meeting, the British APL Association have this biweekly meeting, and I was showing some old code that I converted from some APL 360 code, and I converted it to this my server thing where you can interactive thing, and how I'd mangled the code so you can do things the sort of like session. And it just struck me now that maybe the safe code could do something like where it goes in and replaces all the quad gets tokens, basically, or dual tokens, with something that collects output. So it might not be able to show output in real time, but when you run it, it will collect all the output and show you all the output you sped out on the way. I think I can do it.
Yeah, potentially. Anyway, so look forward to NDC Toronto. It was called Algorithms and Combinators. It was a beautiful talk, folks. And I had a live coded, or well, not live coded, I had a vibe coded live poll that was running like a reverse Cloudflare tunnel on my laptop, and it had this beautiful pie chart animations of showing what languages people were using. only possible thanks to AI. But let's stop talking about AI and start talking about these solutions. So this was 𝗦𝗛𝗢. So 𝗦𝗛𝗢, creator, if you're not familiar, of the Tiny Apple language that we're looking at right now. So this is the index of solution, LOF, or last index of. This is the key solution, and this is the original solution. So, I mean, we can look through these primitives. So this is the group, which I believe initially comes from CAP and BQN, or maybe BQN had it first and CAP added it later. And I don't fully actually, so like this is, so let's remark on the nice things first. So Tiny Apple has the first, although it's called last, and this is the first. So we've got first and last primitives. It's using the CAP syntax for forks in this case. And then we have the, max reduce. We have the decrement function, which is quite nice. What happened to my, oh yeah, there we go, decrement. And this I was a bit confused of at first, but I'm pretty sure backward is just another way for the flip or swap.
No. This is exactly what I was doing before. Look, this is the one that looks at that's the classifier thing, right? We look for the first position in itself.
There's a
over there.
primitive for that?
So there's a backwards is basically a modifier. It's not a normal operator. It's special. I think it's usually a lookup table, and it modifies IOTA to behave
from the
backwards, right? So this is a variant, if you want.
Wow,
really, it's just a spelling scheme.
IOTA of from the end.
Yeah.
So it's basically a primitive that could be spelled with multiple primitives as under reverse, correct?
No.
No.
Then I would have done that, because you have to subtract from its position of the last, right?
Oh, right.
It's a different primitive. It's look for the last element. It's not the same thing as
what I just said. That's incorrect. Yeah. I should have thought
he had the tally minus earlier.
Yeah. And 𝗦𝗛𝗢 in the chat is saying Elias, the creator of CAP, and they added them at the same time for the group primitive. So very beautiful. I mean, we've got the banana brackets in order to get the train syntax. And so this is the only thing that, this is the group primitive from BQN, but it's equal group IOTA tally, which I don't fully, and you can see that I had it here because, except this was a mistake putting this because I wanted to, I don't have, actually I can just go up. Yeah, keep it this way. And you can see that I had it here because I was trying to just evaluate this. And if you get rid of, can you do it without, I don't think you can do it without that. Actually, no, wait, I'm doing this incorrectly. I want to do shift enter. So this, which is just the equal group IOTA tally of the string, gives us the indices of the A, B, and C characters.
Oh, is there some kind of hooky thing going on? It's using the elements as the key into the group. Is it something like that?
Well,
so like it's grouping the indices. That's why it's doing the IOTA tally. So it's giving, you need to get the indices first.
This is just a key, right? This is just,
yeah, but it's a key spelled with like 5 glyphs.
But the IOTA tally is the indices.
Yes, IOTA tally, exactly. That's what I'm saying to Connor, is the data you want to group is the indices, not the. I think if you get rid of that, does it just group the characters? Or is there a write tech or something?
Yeah.
So instead of grouping the characters, you want to group the indices at which they occur, which is the IOTA tally.
What does the equal do?
Yeah, I was going to say, I'm guessing that this has to be a binary operation that's passed to group. No?
Well, no, because you've got the wrong domain there. You can't less than characters, but you might be on to something.
Well, what is equal? Magnetic equal.
Just equal.
Help us, Madeline.
Madeline in the comments. Explain.
My guess is that this is like a higher order function. Although, why is it blue? So
it's classified. Oh, okay. Fine. It's classified. That's fine. So it's just it's grouping.
My docs have failed.
Yeah.
No, because it's Madeline forgot to document it.
Well, we can't blame Madeline yet because my guess is that it is documented and my scraping script missed it. I trust the AI vibe coded doc scraper. Although,
No, Madeline
never
is
mind.
blaming.
It was Madeline's fault. She says, "Oh, I did forget to document it." So this is if we go to BQN quickly, and we delete this. This is and I can never remember how to spell this. I gotta. Is it this one? Is it this one? Is it this one? There we go.
That one
With
is your classify.
There we go. So this is the idiom this is classify, I think, right? So if we do F1, this is
you were right.
classify, and this is group. And this is an idiom that I am very familiar with in BQN because it comes up a ton. So in 𝗦𝗢𝗪, it looks like I guess it would look like this in the case where you were grouping the own stuff. But in this case, you actually want the fork where 𝗦𝗢𝗪 is the right tine. So yeah, this is a fork that is, doing classify group on the indices. Which is, I mean, we haven't said this for the audio listener, but this is definitely the most verbose solution. Then the key shaves off 4 characters or 5, and the index of shaves off 1 more. Although Madeline did mention that the index of for her 𝗦𝗢𝗪 is actually much slower, but that's not because I don't think it couldn't be faster. It's just the implementation currently. Are there any other things worth remarking on? So I mean, it's very. This is why I love 𝗦𝗢𝗪 though, because it's got it's got the last, it's got the first, it's got all the primitives, and so whenever it always makes me so sad when you go to BQN and you want the decode and the encode, or you want the partition primitives, for playing around 𝗦𝗢𝗪, it's always very nice because. And that's the thing is I wasn't even aware of this backward. But you can maximally play around with the different algorithmic solutions for this. And I guess I should delete this at this point.
And it makes me want to find the docs for backward. There it is.
So I
can show other things can do that. Oh, it doesn't say.
If I look at the full docs.
Backward doesn't tell you what things can go backwards, but the things that can go backwards also don't tell you because it was because Madeline forgot to document it. Yeah, okay, fair enough.
I just realized that an optimization that it's a nicer spelling of things, I think.
And I guess this is the problem with not having a full panel, because there was a J solution at one point that didn't use key.
I have a J solution. I have it ready to present. You want me to present?
Yeah, sure.
No,
Steal it away from me.
It
irritates me because this YouTube recording, I'm staring up at my ceiling basically. So it's nicer if someone else's screen share.
First the caveat: I'm not a J programmer, so I don't know what I'm doing here. But this seemed to work, and I just realized something.
Oh, look at that! And we're in Juno, folks. Look at that, dovetailing from episode 124 with.
So this is the index of. This is index of selfie. And this is index of last, which is a primitive in J, selfie. So this is super easy. So subtract those from each other. Maybe I should tokenize this for you because I can't read J like this. Sorry. I mean, it has different colors and it's all nice here, but seriously, I can't. Okay, so index of last, selfie, minus index of first, selfie, maximum, nothing over here. This is the cap. Thing, and then subtract 1. So this is solution. And I just realized
it's together. You can put the slash next to the max.
What?
Right? Is that right? Right. That's one thing.
Yeah, I mean, if you want, but this is
the same with the reduce. Yeah.
Sure. We can put this. So I just realized a couple of things that are nice here. One is, I believe, and we can apply this to the API. We can go back and do the API afterwards. Is we can break out the selfie over here, I believe, like that. That still works because it's now it's just index of the left argument, which is so that's nice. And this, I believe, we can make this an inner product, but inner product is not spelled any better in J really because you have to do like this, I think. do inner product, but that gets rid of the
You need
cap.
the slash as well, or no?
Yeah, in J you do, but not in
You
Intel.
have to- Okay, fair enough.
And then, so this is the whole solution. We can get rid of the spaces now. We can almost
So
read
it's
it.
max dot minus.
We can't remove this space, I believe, because then it's dot slash, which means something completely different. But this is pretty nice, isn't it?
-1 plus the
Slightly
index of
shorter.
the last, max dot minus index of the
And
first.
can't you do a decrement? Or is that going to be longer?
Oh yeah, we can do a decrement, but it doesn't help because I would need a cap
Right.
because you can't do a tops like this, so it doesn't
sad.
really.
That's the worst part of J, folks.
It is-
I can
it
say it
is
because
really,
Henry's
really
not
sad.
here, but the two train being the S combinator, frankly, big mistake.
Oh, as it turns out, slash dot is key in J.
Yeah,
Is that
so we
right?
can use key. Yeah, but it's not just slash dot. I think there's two keys because they realized that the dialog key was so nice that they wanted that too. So this is the key, and then there's like
Well, that was Roger's fault, was it? He brought J stuff into
yeah, key
dialogue.
diet. Yeah, this one. But anyway, so yeah, you can use it the key. I'm not really sure how that works. We can try it if you want, but I'm not. I mean, scary stuff.
Unknown territory here for APL.
So
APL,
key-
APLs.
I think we like enclose that did not work. Oh, right, because we want. I don't even know.
Yeah,
Let's just group them.
that's right. Yeah.
No, it's not because this doesn't give us the indices.
No,
right?
no, you have to provide
Right, I have to provide the indices myself.
feed there. So it's an I dot and then like a hook or something.
We have to do like
Or a compose.
I dot compose with the tally,
Yeah.
just like this or something like that, right? Yeah, so these are the indices, and then we want to group by indices. So we want to group like, oh, I think now we can use the copy thing. Oh, it's from the wrong argument order.
Imagine does J have a regex engine inbuilt?
It looks the same. I don't know how to use key here correctly on the indices. We want to group the indices, but how do we supply what the keys are?
If there's a J programmer in the chat, I mean, there was one earlier, but
They explored the approach to only use the index of first and index of the element in the vector. I'd feel the dot after slash for key. So that's
forgotten
probably
that.
okay.
Yeah, so these are all the indices, right? And so instead of this is the enclose. So I think Marble. We'll come back to what Marble is saying.
Okay.
So here, inside here, we
Okay.
want. Okay, it does the parenthesis thing for me. We want to do the first and the last. There's a head and tail.
yeah, it's brace colon and brace dot.
Open brace and open brace dot. This it's actually the last one you want, right? Last minus first.
Yeah, I can never remember which is which, but you just
There we go.
You try both, and one of them will work.
Exactly. There we go. So now we got this far, and now we just want to do the minimum on this, right? So the minimum is
less than dot
this,
slash.
something like that. But we can't. We have to cap it. No, that's not right. We don't want to do the minimum. We want to do the maximum.
The maximum, yeah.
Why didn't you stop me? And then we want to subtract 1 from this. So -1 plus, or we can decrement, which doesn't help anything. It's just more caps. We could, technically speaking, glue it together with decrement over here. Was decrement minus dot or something? I don't know. Decrement is. Wait, hold on.
Not less of that.
Decrement less than colon. Of course it is.
The
that.
disdain in Adam's voice. Of course it is.
And now it's not right anymore. I don't know. I can't read this stuff.
I mean, we
Business
got
decrement.
we get the impression. Oh, we got
Oh, they have to like.
the bulk of
There you
the
go. It has to
the-
colons because they got like the
Don't
combinators
forget the
from.
colons.
Yeah, it's got extra colons for good order. Ugh.
See, if you were on array
All right.
box, you could have just gone control space and typed in decrement. You never need to memorize anything anymore.
Okay, thank you. That's
Is that true? I'm going on a Raybox now.
Yeah, well, I'll steal it back
so
because
this is interesting, right? Because this means that in J, right, this solution was so much better. The one like so much nicer as well. Actually, read that. Now I want to go back to APL for a moment because if you look at this in G, we could actually. Well, it doesn't actually matter because this is the last index. Sorry.
And I'm going to, by the way, I'm working on a new
It's
keyboard
first index.
solution for Dialog APL. And I'm going to steal APL space as a default shortcut for a keyword search.
APL space or it's control space. So.
Well, it depends where you want your. Maybe it will just be settable to whatever you want.
Okay, yeah. And I wasn't the one that came up with it. It's on. I think Cap has a version of it. There, everything on array box is just an amalgamation of all the best things across every single REPL in all the different array languages.
For sure.
So just what I thought of here is an APL is sort of nice to do an inner product here. I don't know if you like that. It's not shorter. It's just because it's a reduction over vector. Like you could do it. It would be nice if we had like a iota dot whatever, like the index of last.
All right, can I steal it back to show 𝗦𝗛𝗀𝗪's?
Yeah, go ahead.
Technically credits. I'm gonna pronounce this wrong, but I'll do my best. 𝗓𝗛𝗡𝗪 has a optimal 𝗦𝗛 solution, and seeing as we don't have the J representative, we don't have the 𝗦𝗛 representative, we're just doing our best to showcase all the different array languages. So if we come here, and so yeah, this just to highlight on screen what I was mentioning. If you're in J or whatever, or 𝗦𝗛, and you don't know how to type it, I mean, in 𝗦𝗛 you can just type the name of it, so you don't really need this, but you can do stuff and find it, which a lot of the times there's a subset in J and in BQN and definitely in TinyApple that I do not know how to type. Anyway, so this is the optimal by way of 𝗦𝗛𝗀𝗪 from 𝗓𝗛𝗡𝗪 by way of 𝗦𝗛𝗀𝗪 in the YouTube chat. So this is the benefit of doing this on YouTube is we can fill in our lack of expertise in the array languages that we're not good at and borrow them from them. So I believe this is classify in 𝗦𝗛, and then this is unselect, which actually I don't have the
log is classify, bro.
So do they have it? So I don't have the name of this, but there's a bunch of idioms that I scraped from the 𝗦𝗛 docs, and they have names, I think, half the time. So unselected, or like I don't know what it corresponds to, but this is an idiom. Can I not get rid of this? And then we have, I believe this is complement, or not, as they call it, plus. This is minimum, and then
unselect is enumerate an array, right?
Oh
So
yeah,
it's
That's
not-
not iota tally.
what am I doing?
Yeah,
here?
it's-
Let's just get rid of this. Get rid of
It's
this.
called
and
unselect.
I can just yeah, we would have been able to see this if I just evaluated this like this. So yeah, it's enumerate.
Oh,
Zip with index, basically.
Puts iota tally in front of the original array.
in front because it's stack based,
Yeah,
right?
it's stack based. A lot of
Oh,
things are backwards, right? Like every function, including binary operations, are prefix, and so some.
yeah. There's no dyadic. It's stack based, right.
And then if you do not, ooh, actually, that's interesting. The not of your indices is actually 1 minus. Is that right? Did I just do that correctly? 1 minus, yeah. And so because you have 0 index, it's 1, 0, -1, -2, -3, -4. And if we
And then you add those
that,
together, then that is like subtracting the indices from the last from the indices from the first, from the beginning indices. of the last from indices of the first.
This is breaking my brain.
No, yeah, it's there.
So classify totally makes sense. If you have the string ABC, CBA, you get 0, 1, 2, 2, 1, 0. That's fine.
Mm-hmm.
Unselect zips with the indices. Then you take the complement or not of the indices, and that's effectively programmed as 1 minus, which
Yeah, that comes from BQN. It was because of fuzzy logic that the probability of something not happening is 1 minus the probability of something happening. So that's why not is 1 minus.
But in this case, you end up, your indices are transposed to, or not transposed, transformed to 1, 0, negative 1, negative 2, negative 3, negative 4. And then when you add that transformed index sequence with your classify sequence, you end up, for the case of ABC, CBA, 1, 1, 1, 0, negative 2, negative 4.
No, you're right. I'm lost again.
Yeah, I don't know why that makes sense.
Or what it's for. So it's...
And then
what
wait,
is it?
so there is an absolute value at the end, which might make more sense if we do that
No,
here.
it's the distance. It's the distance to the...
Oh, actually, wait, but you need it to be in front because they're doing a minimum here. So
distance to the first one?
This is...
If you go back to the plus, I'm pretty sure that's the distance from this element. Can you stick another C on the end?
Whoops.
Is that the distance that C is 3 characters away from the first C, and the A is 4 characters. 1, 2, 3, 4. Yeah, 4 characters from the first A, and the B is 2 characters from the first B. But the first C is does that make sense? 1, 1, 1, 0.
Yeah. I think
First
you're correct,
C is 0
because
characters from the previous C. Or there are 0 characters in between that and the previous C. And the second one, there are 3 characters between that C and the very first C.
Yeah, because the property of the classify, similar to what Adam was talking about earlier when we were doing the dyadic iota selfie, is that it's the first index. It's not just like the category. It's not just a label. It's the first index of it. And so if you do this, I mean, it's still a little bit mind-bending that...
No, but that's it, right? That's giving you the...
Yeah. It's just a little bit mind-bending because the transform index sequence, it's not 0 to negative 6. It's 1, 0, and then negative 1 to negative 5. But when you add that to the classify, you get back basically a maybe off by 1 distance from the character to the first instance of that character.
Yeah.
Which happens to be exactly what we want. And then the confusing part is that you have to go minimum and then absolute value. I mean...
But why minimum absolute value is just...
Is it though? Because...
well,
you just negate... Madeline says you need to negate.
Otherwise, in that, when they're all different, it's probably...
Absolute negate. Otherwise, when they're all different, you get it wrong. If you do absolute, then negative 1 becomes 1. You don't want that. You want... You want to flip.
All right.
Wild.
J with ligatures sounds amazing. J with ligatures sounds like...
And actually, why did this... Why?
Huh.
Oh, yeah, because I put...
Yeah, maybe that could be interesting.
Max instead of min. So technically, I guess this would be a lot longer in BQN because there's no zip with index. I mean, you could spell it with range pair, but you're going to need at least a before or a fork. It has classify. So, I mean, actually, let's see if I go to BQN, which I believe is right above.
Translate.
So this is, classify, and then this is what... let's just comment this out for the moment. Is that going to work? That did not work. Well, I didn't mean to get rid of everything. So we have classify, And why? I guess this needs to be in a fork. It's not happy.
You're on your own here, Connor, I'm afraid, because
Oh, right. There needs to be a length in here. All right, so this looks right. So here's our classify sequences on the right down here. And then now we have our enumerate, except we don't actually want to enumerate. So we just want this, actually. And now we want to do our complement, if I can type that correctly. And now we want to do, was it plus? Oops, I got rid of something I should have gotten rid of.
it is, yes.
And then the pattern was we want a min,
Negate.
reduce, and then an absolute value, which is
Negate, not absolute.
Negate, not absolute?
Yeah, because if they're all different, -1 becomes. I can't remember the explanation, but
what is negate? It should be minus. Oh, right, but then I'm so close. This is right. I need a nothing before this. There we go. And so can this be golfed?
looks pretty tight to me. I don't know.
Yeah, you can a little bit because you can flip. You have a fork on the right, right? But it's parenthesized left side.
Don't we
So you
still
could just-
need to use something? We'd need to, or I guess maybe
You just
nothing is
glue
what you're
them.
saying?
No, just
You
glue
just
them.
Find the knot,
Another thumb.
rest of
Another
it,
touch.
and then-
Oh yeah, I fail to.
There you
I'm
go.
so fork brained.
I mean, to be fair, like passing wise, I personally like grouping, bits in parentheses, even when I write
Yeah.
trains and
Now
stuff.
he
because
wanted
here
to
I'm like,
golf. So.
oh,
I
my
wanted to
part.
golf though. I mean, I agree that if I'm writing it in code, I probably would have left it like that because this is much more. I agree with Rich. It's much more impenetrable.
You got to figure out there's two jots there, and one of them's doing one thing, and the other one's doing.
Exactly.
Well, I guess it's not, but it is. I don't know.
I wonder if someone like Marshall, if he instantly sees this and then knows dun 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 dun, like that's a unary function and that's a fork, or I don't know. What you guys are the pros. I guess Rich, you said it's still hard to parse. What about you, Adam? Do you instantly see this?
Yeah. I've gone over the other side of Tacit. Less of a.
I sort of see those groups together, but it bothers me that things that are adjacent with no combinator between them are more distant from each other than things that are bound together. So people are saying in the chat that that J with ligatures might be interesting.
Yeah, that's nice,
I'm
because
thinking
now your concepts actually.
It still spans the width of two characters, though. So I don't know what we're talking about here.
It didn't have to. It could be variable width, right?
Is it?
So
I've
no,
never
but
had
I'm
a
thinking
thought that the ligature changes two characters into a single character. Is that possible?
yes, you have, but you never notice because those are not coding fonts, right?
Yeah.
Because any normal font.
Fair enough. I'm talking about JetBrains Mono and sibling fonts that have ligatures.
If you write FJ, lowercase f, lowercase j in the normal font, it puts the f and the j together. That's where ligature comes from. Using it for programming is a hack. Right. Or fi, right? It's a classic one. Anyway, so maybe for API code, I don't mind so much it being variable width. For arrays, they need to be monospace. But let's just say there was a way to make that all work out. Imagine if the spacing between the glyphs was larger when there was no combinator between them, but then the combinator was narrow and pulled them together so they would sort of look nicer. So healing. Yeah.
I guess I'm kind of code golf brain. So my desire is that when you have if you're trying to replace 1 plus or some equivalent with increment, it's well, what did I actually do there? It's only useful if you need some tacit thing and it saves you a cap or whatever because you can keep things in some fork mode or whatever. But Tiny Apple is much better in my opinion because it's a single Unicode symbol. Anyways, have we missed? There's been a bunch of comments in the YouTube chat. as we wind things down, seeing as we're a full half hour past the 90-minute
Yeah,
mark. I like how Rich was
I
like,
have a.
"Oh, we got to share the tiny apple. It's at 83-minute mark, and then boom,
Oh, I
40.
didn't realize there was a desire to keep it at 90.
Oh, I
I
thought
I
that's
have
what you were
a.
getting
Was
to.
that established in the first 5 minutes when I
it's
wasn't here?
ever
That it
since
was.
No.
ever since the beginning of a
I
Raycast, there's supposed to be 90
I
minute
did kind
episodes.
of yeah. But I did kind of look at the lengths. No, I
Okay,
didn't.
so I have a final entry here, which is writing Perl in APL, basically solving
Pearl?
this using regex in dialog APL. No, the wrong tool for the job. Let's do it.
Yeah.
All right.
Okay.
Although my wife said I've got 2 minutes, so hopefully you can do
Yeah,
this in 2 minutes.
I think so. So I think this works. I haven't made it into a single function, although that shouldn't be hard. I think it just comes out to a train. So we can do that, but
there's
it looks
an APL
completely
in there.
insane. Yeah. Okay. So what's happening here is essentially this is the search function, and it's looking for any one character followed by any number of characters and then a back reference to the same character again, which is what we're looking for, right? So any sequence that begins and ends with the same character, we don't care whatever is in the middle, and it's greedy, so it wants to make them as long as possible, but we want to catch overlapping matches. So this is the variant that says overlapping matches is set to 1. And we don't actually want the result of the search. We just want to know the length of the result, which is the code 1 for the result. Instead of returning a text, we return that over there. So I'll shorten this for a moment, just over here, and use the and symbol. This gives us all the matches that it could find. If we add some more, like some B's in here, so we can see that we find the maximum A up here up to B, right? So these are all the possibilities, all the candidates. But we don't want that, we just want the length of each one. So we replace this with a 1. So this is length 8. And then we want to subtract, but remember this counts the length of the first and the last character included. We only want actually the length of the middle one. So we could extract the middle one, but it's easier to just subtract 1 from it here. Is that actually true? Is that shouldn't we subtract 2? Let's make a shorter example just to see here. So this should give us, yes, oh, this gives length 2. So we need to subtract 2 over here. And then there's one problem, that is if there aren't any matches, we need to get -1. So if there aren't any matches, it gives us an empty list. And then we try to do the maximum empty list. That's no good, because that gives us the identity element, which is -infinity. So we don't want that. So actually, we could be trickery with this, but whatever. So this is this gives us 3, 1, 2, 3. That's this one over here. And if there aren't any matches, we get -1 because I just stuck that in there. But the problem is we get -infinity. So there is something we could do here. We could be a little bit tricky and just say like -1 with maxed with that, but that's just silly. It doesn't save us anything. Anyway, so this is a solution using regex in dialog APL. Forget you ever saw this. Don't do this. This is for sure going to be the slowest solution of them all, and it only works on characters. So yeah, never mind. You'll also fail on all kinds of other things. Well, now you've seen that.
There we go, folks.
Shall we call it a day?
We should call it a day. He didn't do it in 2 minutes, but 3.5 is pretty good. And doing Perl better than Perl, does it. Technically, this problem came from Perl Weekly Challenge. But every once in a while, I look at the Perl solutions, and they try and make it look like Python and like very variables all over the place. And I tried to find the solution. They don't have it, but the solution for the first one is like hardly using regex at all. So APL, doing Perl better than Perl. And I guess that's where we'll leave it. So we saw, what did we see? We saw some J, we saw some APL, we saw some Tiny Apple, we saw some 𝗦𝗛𝗢. We did see a little bit of BQN at the end too. And the only thing we didn't see is cap. So I guess we got to bring Elias on or something to make up for that at some point. Thanks to Adam and Rich for hopping on and chatting about this. I think this honestly turned out so much better than, not that I thought it was going to be bad, but I didn't think it was going to be one of our better episodes of covering a bunch of different primitives and solutions. If folks have their solutions post the live recording of this, feel free to share them in the YouTube comments. You can also reach us at contact@𝗡𝗢𝗪cast.com. If we have access to the email, I think we kind of quasi got blocked out. Adam, I need to figure that out.
I need to look into that. Yeah.
Luckily, you can log into the YouTube account without having to log into the Gmail first. So I was worried that we lost access to the YouTube account, but we still have access to that. Once again, thanks. And I guess with that, we will say happy array
programming.
Oh, it's been a while. Happy array programming. I didn't know you can do it at the same time. It doesn't matter.
No, the way we do it at the same time is that when he says that will say, that's when you have to say happy array programming.
Yeah, but
and
before, back in the day, in the old days, it was he'd say it and then everyone would say it.
Yeah. And if we didn't even say
but that's because you would fix it in post.
Yeah. But now we're live. Things are different. Anyways, thanks guys. We'll do this again sometime.
All right.
Right.
Great to see you.